Yeah, I promise this will be a little bit different as I attended all the other talks. Yeah, I will say different. I will stop here. Yeah. I will try to wrap up my call in like 30 minutes and give you 10 minutes for a question, or maybe 5 minutes. And we still have all the night, right, to discuss and take question yeah, offline, right? So that's basically it. Yeah, hello everybody. So my name is Slim Baltaji, and I'm working at Capitolone, which is a financial corporation. We are based in Chicago. No, we are based in DC actually, but I work in Chicago, and we have offices in US, UK, and also Canada. So at least it's good to start with telling a little, yeah, something about the company I work for, and I'm a director of enterprise architecture. Yeah, today many people ask me if I am a Flink committer. So I will answer I'm not a Flink committer, but I'm committed to Flink. How about that? So that's what it is actually. Yeah, so that's what it is actually. Yeah, nobody is paying me to talk about Flink, but it's a technology that I like, and I want actually to evangelize. I did this actually in a few countries. How about that? Recently I was in Brazil, gave a talk in Sao Paulo. I'm here in Dublin. Next month I'm in China, and a huge number actually will be attending. So hopefully I'm doing my part, not with code, but talking about this tool. The agenda for today is the following. So how Apache Flink is a multi-purpose big data analytics framework. It's not only about streaming analytics. I will quickly talk about the different facets of Flink. Why streaming analytics are emerging. So I would like to put some context before even we talk about the technical aspect about this tool. I will focus or emphasize on an era which I call streaming era. So what's going on, and hopefully you'll see some like maybe some different type of thinking here. Why Flink is suitable for real-world streaming analytics. Most of the time I'm seeing in blogs and in discussion, the focus is on real-time streaming versus whatever microbatch. I think I would like to take it to a different territory. So I think it's more about real-world streaming analytics, and I will explain in my talks. Also something interesting, what are some novel use cases enabled by Flink? One of the talks today, we were told about some design pattern for streaming architecture. We will see how Flink actually takes this to another level, and you can see a new type of use case of Flink. And at the end, I always, people who are wondering who is using Flink, and even as today, I heard that for the last 2 years, Flink, whatever is working on streaming, which is not correct, actually, it's only 1 year, I think. And there is already a growing number of companies who are using Flink, so it's for you, if you got interest in this technology, always it's natural question to ask who is using it, right? And the last thing is where to go from here. I will share a few references, a few web resources for you to get going. Yeah, here we go. So I spent some time on the agenda so you can have a good idea about the talk from start to finish. So if you take, so for me, when I say, I will explain quickly why Flink is considered multi-purpose big data analytics through 3 things: the Flink stack, also why I call it the 4G of big data analytics frameworks, and what are Apache Flink innovation, because what's going on, I won't say competitor, but other framework that are catching up. The Flink is coming with a lot of innovation, and the natural question is still: is there still a room for Flink, or basically the question: what is still there that Flink has and what other don't have? I think this may be something interesting to share with you. How about we go to this stack and we will spend a couple of minutes on it. Basically, this is not specific to Flink. So if you pick any big data analytics stack, basically you have 3 layers, right? Flink is not different here. So high level here, you might say, whoa, this is another Spark. But let's dig into it. So I won't spend time on the storage and the deploy stack. When it comes to storage, I coined the word bring your own storage. I live in the US, and you see in front of a restaurant, I don't know if this is the case here, buy OB, so bring your own beverage. So basically you get to the restaurant and you are free to bring any type of wine you want to drink. Flink is doing the same when it comes to storage, and this is not specific to Flink. Spark is already doing that. When it comes to deployment, you have many ways to deploy Flink. It's already works good integration with the Yarn and the upcoming integration with Mesos, so that's work in progress. So what's specific about Flink? That the core engine is a streaming one. We will stop on, and the slides will focus more on that. This is a major differentiator. So it's a streaming engine, and you are modeling or running batch jobs on top of streaming engine. That's kind of like a novelty here, and this is unique to Flink. You don't have this anywhere. So that's, let's say it clearly, actually. The other thing now, you have some optimization, and we show this especially for batch processing. The last layer is what? API and libraries. So when it comes to API, you have a dataset API, and you have a data stream API. Now I'm using some color code here, so to differentiate two things. There are libraries which are coming from Flink, such as FlinkML for machine learning, Table for relational queries, Jelly for graph processing. So the other color in orange are the following. You see Hadoop MapReduce, Cascading, Apache Beam. What these are doing out there. And when it comes to the stream processing, data stream API, you see Storm and Apache Beam. This is kind of like unique to Flink, that this engine is so versatile that it allows you to run many other workloads. And to actually, from like a business perspective, you can actually leverage your existing investment. What does this mean? So it happens if you have like plain Hadoop MapReduce written in Java, a lot of code. Now you can benefit from Flink by just running that existing code with no change of the code. Isn't it pretty? When it comes to cascading, same thing. Just one line, actually, it's not a configuration yet, one line, and you recompile and you run it as it is, and you gain a lot of things. Same thing, actually, when it comes to Storm. We saw today, actually, a talk about Storm 1.0. As you can tell, actually, Storm is catching up. There is nothing wrong with that. That's good. That's healthy, right, for the community to have open sources about choice, right? But the idea here, you can take your existing Storm pipeline and run then on Flink, powerful engine. That's kind of about it. Now, when it comes to the stack. Now, I'm calling Flink as the 4G of big data analytics. Back in August 17, 2015 of last year, there is a conference called Big Data Scala, and they invited me to give a talk. So the organizer asked me, what's the title of your talk? I said, why Flink is the 4G of big data analytics. He told me, really? Are you aware that this is mostly a Spark conference, and you are kind of like throwing yourself in a cage of lines? I say, not a problem. So that's what it is. And I think that was helpful, actually, or some people were pissed off, sorry to say that. But that's the reality of things, right? So I'm doing this as a hobby, actually, right? So I'm free, and I'm just sharing I'm a free thinker, actually. So when it comes to 4G, this is very simplistic view. You start with Hadoop MapReduce batch, right? That's the first generation. You have tests from Hortonworks. This is mainly like Hortonworks, kind of like conference, right? And then they were able, actually, by the way, I'm an ex-Horton worker. I used to work for Hortonworks, but now I'm free. I don't work for a vendor. So, so I can say anything, right? That's the beauty of it. So with Tez, you have batch and you have interactive. So basically, with Tez, you are able to speed up like pig and hive type of jobs. Now with the Spark, you have batch interactive, and you have near real time. Sorry, I need to use this one because that's what's used actually in the marketing available out there. So they keep saying real time. I will say, no, it's near real time. So as it's kind of like micro batch, and I will explain a little bit more. Iterative processing, also Spark bringing it, especially when it comes actually to using the RDD, and you can cache the data and use it. But you'll see that the Flink is taking this to the next level, and that's why I call it a 4G, 4th generation. So what's specific? The engine is not a batch engine, it's a streaming engine. So here you are seeing kind of like hybrid engine. Think about it like a gas and electricity, right? Interactive, here you have it, real-time streaming. So that's basically in reference to low latency and even ultra-low latency type of use case. And here what I'm saying when it comes to 4G, real-world streaming. What I mean by real-world streaming. So in real world, as I will be explaining in my slides, there are situations when like streams come out of order. When you need to have a session, when it comes to windowings, you cannot work with a specific like time for like your micro batch. Session is, let's say, user web session. Somebody starts doing something and then he logs off. CEP, like complex event processing, which are usually a different tool. Usually you need to have a separate tool to do complex event processing, basically finding pattern in your streamings. You don't need that with Flink. You can do this at the same with the same actually platform. I call it now, not framework. Native iteration processing. I also so there is a built-in operator which allows you to do this iteration, and they dramatically boost the performance of machine learning and graph processing. So I know all the talks today mostly focus on streaming, and I wanted to take some time and to focus on these two aspects. Now, what are Flink innovation? Let's say it clearly, Flink came with many innovation, right? So some of these innovation are influencing quite a few features and other frameworks. Let me specify this very quickly. When it comes to custom memory management and binary processing in Flink, that was there from day one. And this inspired Apache Spark to do so for its project Tungsten since version 1.6. I may get in trouble, but if you read the documentation of the project Tungsten, it looks like mostly not word by word. Yeah, Flink documentation. Not a problem, that's healthy, right? Yeah, when it comes to the dataset API, here I promise I will give you like 2 stickers. I don't have many, actually, I will share them here on the table. But whoever will find here, spot the difference here. Dataset API is in Flink since its early days, right? And inspired Apache Spark to come with its dataset API in version 1.6. Who can spot the difference here, please? Very quickly. So what's the difference here? Sorry? Okay, you will have 2 stickers. Here we go. So maybe you can do it now or after the talk, okay? So yeah, that's good catch actually. So that's the major differentiator, okay? What are Apache Flink innovation? Okay, what's more actually? Flink rich windowing semantics for streaming. You can see this actually in the Storm 1.0, which I came yesterday actually, and now it's kind of adopting this type of rich windowing. That's good. To give credit to Google, actually it's Google who influenced this trend with their Google Dataflow, which they open source and make it Apache Beam for batch and stream. So that's how they measured it, and that's how the word Beam came out. But here we are saying that in the open source, right? So and we are talking about engine. So Flink is the first one to do to support this type of rich windowing semantics, and I will share more details about that. So what we are trying to say here, Flink Storm 1.0 was released on April 12th. Yesterday, so today is April 13. I have the habit of working on my slide and the last minute, actually. So that's what it is. I cannot stop from doing that. And Spark Streaming version 2.0 is expected in May 2016, and it will also support windowing. So this is interesting. So what is left? So if this other framework are getting inspired from Flink, is there still something that Flink has which is kind of like specific, which is kind of like maybe differentiator? So I asked myself this question, I came with a few of them. The first thing is that engine, unless you change it, so maybe that's kind of like the solution that you have, is still unique in a way that it's a streaming engine which is supporting a batch. Not only that, but also it's supporting many use cases. Because Apache Apex, which somebody also was brought up in one of the talks, does have this feature that it's kind of like hybrid. You can have streaming and batch, but it's lacking the support for other use cases. So until now, Flink is unique in that aspect. Native iteration, I already talked about that, so I will skip it. This is just a diagram which is representing that idea of Flink is unique in a way that it's a streaming engine supporting batch and many other workloads. What else is left? Something is maybe interesting to share. Simplicity of configuration. So I'm coming from the Hadoop world, obviously. I remember in the old days, there is 300 parameter to configure. So that's kind of like, this is crazy, right? So now when it comes to Flink, go check what's that configuration file. So flink conf.yaml or something. Check it out. There is not much actually to configure, which is really interesting. How about now when it comes to tuning? Tuning is something that a lot of companies will be suffering from when they go to production. You do a POC where it looks like things are great. The sky is clear, so blue sky, everything. And then all of a sudden you move to a production and the hell comes out. So what's going on here, right? So this is a true actually thing that I'm quoting somebody actually who claimed to be the guy, who strategist, who brought Spark to the Hadoop community. Let's read this one. I won't read his name, but he's saying Spark is too knobby, okay? It has too many tuning parameters and they need constant adjustment as workloads, data volumes, user counts change. So this is a true problem. Flink doesn't have this problem. So we just things work. So you move from local to whatever, pre-production to production, and you don't have that much need of continuous tuning, and you don't need that much of knobs to tune. And this is, so if somebody is maybe shocked with this statement, I'm not making it up. So this is the reference. I assure you every single claim here in this talk is backed by a reference or whatever, right? So you have the reference embedded in this slide. So what else is left here? So full support of Apache Beam, we already mentioned that, right? So we are seeing here a trend, right? Flink came with this trend of unification of the engine, right? Through low latency and with batch. Google Dataflow, they came with this API unification, right? So still here, I won't say Flink beats Google, but Google is almost, sorry to say that, the god when it comes to big data. But at least here you have a differentiator from the open source community. That Google, they have one single API, right, for batch and for streaming, and that's what you have in your Apache Beam. But they have two engines underneath. So one is Flume Java and the other Millwheel. So Flink here is different. You have two APIs, and you have a single engine. But nothing prevents you from going using Apache Beam. Actually, you can see that many committers from the Apache Flink community or project, they are also committed in Apache Beam. So now you can use a single API and you have a single engine. Obviously, Flink is not the only runner. Spark also is another runner. But as I can show in another slide, it doesn't support, especially when it comes to streaming, full feature that are available in Apache Beam. What is the other innovation? Innovation in stream processing. So like event time, rich streaming window operation, save points, whatever. So these ones, we will detail them in a minute. So this is number 6. What's number 7? Number 7 is the Flink CEP. We already mentioned that, right? So traditionally, you need to have two tools, one for complex event processing and one for streaming, not anymore with Flink. So you have a library which came recently, 7 days ago actually, the blog, not the library. The library is there already in 1.0, right, since April 8th, 2016 of this year. What's the last one? Run legacy big data application on Flink. I already mentioned that, right? Maybe this may seem a little bit provocative or something. What I'm saying here, you see this, you see that, that's interesting. You see that elephant on top of squirrel, right? So yeah, that's what's interesting, actually. And you see that cascading and you see storm, right? I won't be surprised actually to see one day, right, another kind like compatibility layer, right, for Spark. Yeah, I'm dreaming about one day when Spark become also legacy application like others. And then you can have Flink, yeah, running, saving you from just losing the time and the effort that you invested, right? Yeah. Okay, why streaming analytics are emerging? This is very important, right? So a very famous professor, right, Stonebreaker, he already predicted in 2005 that there will come a day when streaming will become very important. But he was attributing this to only one reason, right? He's saying to what he's calling the sensorization of the world, which means, right, if I read it, this sensorization of the real world, everything of material significance of the planet gets sensor tagged. And I think he's missing a few points here. I will share what I mean by that, right? So let's pick the first one. So he was mentioning sensor, right? This is just a representation actually of what I'm claiming here. Emergence of streaming analytics is due to many factors: the data streams, the technology, the business, and the customer. Let's go one by one. So when you pick data streams, so you see that what he mentioned, sensor networks data is only one, right? But what we are trying to say here, real world data is all streams. So life is happening, life is in motion, right? It's not, so it's available as a series of events, and you can weblogs, think about weblogs, database transactions, system logs, tweets, click streams, everything. So it's not a just sensor. Now, when it comes to technology, let's say it, and kudos to the Apache Kafka project, I think this is the backbone of all streaming architecture. So you like it or not, that's the reality, right? So without maybe Apache Kafka, we won't see all this innovation and the emergence of these many streaming analytics tools. So we are seeing also rapidly maturing open source streaming analytics, mentioning this is not an exhaustive list. Also cloud services. So you see big names such as actually, I'm not asking for anything free here, but it happened that I'm mentioning that. Google or Microsoft or Amazon or IBM, you see all these big names, they are having offerings to streaming analytics on the cloud. So they are seeing this coming too. The vendor innovating in this space, I mentioned a few of them. Data Artisan, that is kind of like a startup company in Germany, in Berlin. They are actually the supporter of Apache Flink, but you see more like Data Torrent for Apache Apex, whatever, Stream, Databricks, you name it. The other thing, more mobile devices than human beings, at least in the US. This is true story. So there is more human devices than the US population. It's not about the number here, but it's about all the capability that this device is bringing to you, all this GPS and all this interaction with application, whatever, so to see that a huge amount of data coming. So when it comes to the business here, there is a lag between data creation and actionable insights. So I want to read this one. So basically what we are trying to say here, even there is a startup which are disrupting the existing big names. I will pick one, for example, here when it comes to startups such as the one when you pay as you go insurance. So basically there are insurance with 100 years of existence, and now company startups coming from nowhere with less than 10 members, and they're coming with new services, right? Where you just pay as you go when it comes to insurance. This is so maybe to summarize this, we can say the speed is now the currency of business. When it comes to the customer, right? So what's interesting, you and me, right? Every day we are interacting with Twitter, LinkedIn, Facebook, you name it, right? I don't have a Facebook account, by the way, but I have a Twitter one. So I would share my handle at the end of the talk. So what we are trying to say, you are used to this interaction, right? Fast interaction with, and even this young generation who are playing a lot of video games, they are also coming as consumer. So the mindset or the kind of like behavior is being also into like using or expecting things happening in real time, things fast, and this streaming technology allowed this kind of things. So why Flink is suitable for real world streaming analytics? So here I will share two things. One is the feature of Flink, and one is some use cases suitable for Flink. So I will go, I already mentioned that Flink 1.0 was released in March 8, 2016. What I'm claiming here is this unique feature of Flink make it an excellent choice, or I say unique choice for real-time streaming. Let's go here, let's read them one by one. So pipeline and processing engine, I already touched on that, right? Second one is the stream abstraction. We'll go through it quickly. The performance, low latency and high throughput, support for rich windowing, semantics, support for different notion of time, stateful stream processing, fault tolerance and correctness, high availability, back pressure handling, expressive API, support for batch, integration with the Hadoop ecosystem. What I'm saying here, if you take all these features, you can't find them in any other streaming analytics. If somebody doesn't agree, ask a question at the end of this talk, and or even offline, we can continue this discussion. So that's my claim here. When we take all these features, which I think they are fundamental for a streaming analytics tool, you don't find them anywhere. So you find them some of this tool, some in another tool, but so that's the idea here. So I won't spend much time on this one. We already mentioned that. Stream abstraction. So as we said it in real word, right? I will keep using this. So things are moving, right? And it's not like you stop them. Your heartbeat is continuously actually non-stop, right? So that's kind of like the bloodstream and many other things that you observe and you see. That's how it happened in the real world. And when it comes to abstraction stream, Flink is using that correct abstraction. Another tool is using microbatch. It works for them for many use cases, but not for all real world type of use case. low latency and the high throughput. So we are talking about latency in the milliseconds here and high throughput for kind of like 15 in the millions of events per second. And I won't spend much time on it. I'm watching the clock here. There is this reference when I'm mentioning actually good Yahoo article, which was released on or published on December 18th. And then this data artisan, they took this benchmark and they updated it, so that the details will be available for you. As any other talk said the thing, right? Performance is based on your own use case, right? And with own logic that you implemented, and also based on the version of the tool, as these things keep moving and very, very, very quickly. Yeah, support for rich windowing semantics. For example, at this time, right, Spark supports only windows based on time. So when we say window, it's a kind of grouping of events. So you can, this can be based on time. You say all records of the last 5 minutes, or the count, the last 10 events, or a session, as we give an example of a web user session. For example, Spark at this time, right, only supports only one type, which is the time-based type of Windows. Flink supports all of them. There is a very interesting, actually, post from Google, which is explaining these things in detail. And these are two excellent, actually, posts. One is called Streaming 101 and Streaming 102. I assure you, if you read these two papers, you will get a very good idea about the streaming, and you will understand how all these tools compare. Support for different notion of time. I think also another talk touched on that. Event time, ingestion time, processing time. I won't spend more time on that. When we say that's when it comes to real world use case, you need to support all this type of. Here another also from blog from Google, and obviously from this Apache Beam in particular, and where it's showing how this processing time is supported through the different tools available out there, from the Beam model, Google Dataflow, Apache Flink, and Apache Spark. Stateful stream processing. So you know what, you can pick an event and you do something on it. Let's say you are parsing it, but that's not, this is a really primitive way, right? In the real world application, you are doing more about the stream, like such as you do some calculation and you need to store it somewhere. So that's what is called stateful stream processing. Obviously, Flink is very good at supporting that, and you need to store it somewhere. So you have different options, either in memory or in the file system, and recently in RocksDB. So that's what's interesting. So this opened the door to, we'll see it later, for a novel type of use case. Also another feature which came in Flink 1.0 is save points. So basically, this is still manual, but at least it's a kind of good progress. So basically, you don't need to stop your application, but you just take, basically it's kind of like snapshot at that specific time, and then you can, let's say, upgrade your code, or you restart whatever your job without completely actually stopping your existing application. Here I will skip this one. Actually, I see other talks already touched on this, so I can have some time more about the use case. This is a bunch of lists, resources about the fault tolerance. High availability also is something in real world, so streaming analytics need to be reliable. So they need to work non-stop, actually 24 hours, as they say, it's 7 days a week, 365 days a year, whatever, right? So that's kind of, obviously you need this built in, and you have this in back pressure also, I will say here real world. What I mean real world, right? So in the real world, things actually, even let's say when it comes to shopping or events or whatever, so you can see like fluctuation in the number of users. And so what's happened actually here, so you can have a situation when your system is receiving more data than it can normally process. And this is called back pressure. In the case of Spark, this is, so they had a hard time building this feature, and it's still not fully actually baked. You can check the Jira, it's not even closed. And at the end, it's coming with the configuration, right? And by default, it's the Spark streaming back pressure enabled is false. I'm just wondering why they're doing that. Is it because of overhead? So as a technical guy, I will like to have it. If this is bringing me or fixing a problem, I will prefer to see it, by default enabled. So what I'm trying to say here, so I won't touch much about the API. It's very similar to Spark, so let's say it. And Spark actually pioneered this ease of use for the API. So all days, the ancestor of Flink, Stratosphere, did not have that very nice API as it has now. So maybe here some influences from Spark, which is good actually, so there is nothing wrong with that. Yeah, support for batch. This is good for to know that, because if you compare, for example, Flink with Apex, in Apex they can read files, whatever, but they don't have all this type machine learning or graph processing. So this is a plus here when comparing to Spark, Flink to Spark. So obviously Spark, they have a good support, very good support actually for batch. Yeah, I stole this one from one of the talks from one of the committer actually, and did not have time to update it. This is not up to date. There is obviously, this is growing, and there is many actually other things which integrate with the Hadoop ecosystem, because always the question, does this integrate with Yarn? The answer is yes. Even now with Mesos is coming, and obviously whatever you are familiar with from the Hadoop ecosystem, you can use it. So here, this is interesting. What are some streaming analytics use case? What I'm trying to say here, so when you understand all these features of Flink, you can map them to the use case. Let me pick a concrete example, actually, which I shared yesterday because I gave a similar talk, not exactly this one, to the Hadoop user group in IRL. Actually, something funny to share with you, maybe. So before going from the hotel to that meetup, it's called the Hadoop User Group Ireland. So the acronym is HUG space IRL. So I Google for it, and what do you know what comes out? So the first thing, do you mean hug a girl? I say, no, that's not what I mean. The second one came with, kind of like home, home and welcome the greyhounds or something. So that's interesting how actually, maybe Google here is behaving here. So it's, I find this odd, and I'm just sharing this with you. Yeah, what's happening here? Let's pick a concrete example. So some years ago, I went to a store, furniture store with my wife, actually, and my kids, and we wanted to buy some furniture. This is true story. And then what happened, actually, we have the credit card from the store, and we went over the limit. We were about to leave. Sorry. But the guy, the salesperson, is excellent, the guy. So he told us, please hold on. So he brought us a coffee and asked my kids, give them a couple toys to play with. And he spent like 15 to 20 minutes on the phone with a lady from the bank, kind of like maybe convincing her or something. Anyway, after 15 or 20 minutes, he say, good news, your credit card, you got the credit card increase, and now you can have the furniture, and it will be delivered to you in a couple of weeks. So imagine a world, imagine like in the song of John Lennon, right? So imagine a world when instead of this happening, like a situation when the customer actually is losing, right? You cannot buy the stuff, the vendor is unhappy, right? And the bank is unhappy, they are not making that money, right? For this transaction. When you can make a quick call, right, to a scoring model, right? And you can have that answer, yes or no, about bumping that credit card limit and enabling this transaction instead of canceling it. So this is called in financial service credit line CLIP, credit line increase processing. So this is true story. Now maybe few banks are doing it. I cannot share more. So that's what it is actually. So this is a concrete example. You can go on and on with every single like vertical when you can map this. You pick like advertisement serving. The requirement here is to serve an ad in under 80 milliseconds. That's the requirement, right? Obviously, Spark gets out from the beginning here. You cannot have these type of things. So that's what I'm trying to say. So based on your requirement, map them to your use case, and you find out that Flink actually supports many of them. What are the some novel cases here? So what's interesting, so thanks to the stream processor, so the use case is Flink as an embedded key value data store. So what does this mean? Instead of pushing the state, right, let's say doing computation to a data store such as Redis and then querying it, now you can turn Flink into a database, in particular key value data store, which is interesting, and this is opening the door for many interesting use cases. There is a couple details here, a couple slides, this one, and they have a link to the blog. And the Flink actually are planning this to have this part of the framework itself, so you don't need to do any custom logic for querying the state. And this is upcoming in 1.0, so if Ufuk is in this room, I asked him yesterday, Flink 1.1, he said, but maybe here. So yeah, it may come to another version, but at least that's kind of like the plan. So as you can tell here, so you can have query services and you can get the state, let's say computation or whatever. So this is very interesting. So the other thing is distributed, let's say it again, distributed complex event processing. So it's not a common, even your common tool that you will get from the commercial shelves, right? Doesn't have this feature that it's a distributed one. So here we are talking about even when it comes to latency, you can have like ultra low latency type of use case, and with the complex event processing. Complex event processing in this case is detecting pattern, right? And I think Ufuk today in his talk showed us a concrete example. I will say, let's say in cybersecurity also, this is very well-known type of use case when you will need this type of complex event processing. Now the question, who is using Flink? So that's very interesting. It's interesting that the first application came, the first company from France to use Flink. It's called Bouygues Telecom, and it was very interesting. So the guy attended the talk back in January of last year, came back to his office, implemented it, and basically that's what happened. You have a few more. Today we heard from Gyula, right? His use case from in Sweden from King. So that's in the gaming, and it was very demanding. Type of use case. The other use case from retail, Auto Group, I'm sure especially European people are very familiar with these names versus people in the US, Zalando, Ball.com, that came recently, and I have the pleasure to meet the guy, the architect who did that today. Yeah, pure coincidence. Security also Firelace. Capitolone in the US, not a single company is using it yet in production, and we are not also using it in production. Let's say all these ones are using it in production. We are in pre-production. I cannot go more in details why we are still in pre-production or production, but at least let's tell you we used the Flink, and we were able to show that we can replace a very expensive commercial tool with a combination of Flink and a couple other use cases. Here, I won't say that the Twitter and Yahoo are using Flinks, but the links here that I'm providing are eye-opening so that you can tell what the value Flink brings to kind of like legacy applications. So that's what's interesting. In all these use cases, they are all following this pattern, right? So basically you have a producer, collector, broker, processor, indexer, visualizer, and search. And you have here in every single kind of category, I'm listing a few of the tools. So it's not just Flink, so this is happening everywhere. So what's specific about Flink? Flink is bringing few novel use cases. So at the kind of like the processor level, you can do things such as alerts, right, that you cannot do in Spark, for example. And these upcoming features are querying also the state and the Flink CP, which is already available. So what we are trying to say, so it's not always the common design pattern, but with Flink you are saying a couple ones. So where do you go from here? Obviously, this is shameless plug. And my hobby, actually, especially very early in the morning while my wife and kids are still asleep. So I'm checking what's going on in the big data space, and for years, and yeah, updating this website. It's called Spark Big Data. So you can tell that in the past I was also evangelizing Spark, but now I'm becoming more like a Flink, not committer, but committed to Flink, as I said. And here you have thousands of resources about Hadoop, big data in general. When it comes to Flink, I think it has the most exhaustive list. Maybe it's unique. There are over 700 resources about Flink. The other thing, obviously, the link from the Apache Software Foundation. Interesting to mention that there is a free Apache Flink training from Data Artisan. I strongly encourage you actually to get your hands dirty and play with that. The example when it comes to streaming is about taxi rides. It's a very, very, very interesting one. You can even also use another blog when you can show yeah, the power of that use case. Flink Forward Conference, I happen to learn this today, actually, so I update my slide. So the call for submission just announced today. So Flink Forward will be happening in Berlin, Germany, the 12th and 14th of September. There is a free ebook, and I have the chance to get the autograph from, yeah, from the author, the two of the author themselves. You know what? I swear they are not paying me to say that, but this is a book that I wrote while coming from Sao Paulo to Chicago after giving a talk on Flink. And this is an excellent book. You can get it for free. And I swear they are not even paying me a coffee or something. And this is not an invitation for them to pay me anything. But just telling you, I like the book and check it out on yourself, by yourself. I will say something in this last minute. So Apache Flink have unique capabilities that enable new sophisticated use case, especially for real-world streaming analytics. I will say that even people will wonder now if Hortonworks or MapR or Cloudera doesn't actually support it. I will say this will be coming. And the last thing I will say, and maybe you can take this discussion offline, what would be the 5th generation of big data analytics? So we were talking about 4th generation. It doesn't stop, it will continue. So I am suggesting guiding principle here to come with this 5th generation. Unification, simplification, and ease of use. So this acronym becomes like use. A GUI to build batch and streaming analytics. There is not a single thing like that, but you can build one on top of Apache Beam. So that's the first one. Unified API for batch and streaming, you have one, which is called Apache Beam. Single engine for batch and streaming, you have Flink. A unified storage layer, files, streams, and NoSQL. Unfortunately, this is only available in MapR distribution. Unified query engine for SQL, NoSQL, and structure. There is a tool which is almost there. So with this one, I would like to thank all of you, and let's keep in touch. These are my contacts, my email, my Twitter handle, and the links. And if we don't have the chance to ask question, I will actually, the recording will stop. I will take your question right now and also during the dinner. Thanks a lot for your for attending, and yeah, I'm open to your question. Yes, please. Yeah, it's showing that we have 30 seconds. This means it's not very practical, but I swear, actually. And also, I have the, yeah, I covered, right? I'm covered because my back is covered. We have some Flink committer in the room, right? So in case you come with a very sophisticated type of question, we can actually answer it. Thank you.